Welcome, everyone. Today, we're diving into a fascinating topic that affects us all: Earth's magnetic field and its incredible role as our planet's shield. Did you know that over the past 3,000 years, our magnetic field has lost about 30% of its strength, and it's still declining? But here's the twist. This might just be the beginning of something much bigger. Stick with me as we explore how this invisible force protects us every day and what could happen if it continues to weaken. Think of Earth as a giant bar magnet, but instead of a solid piece of metal, the source of our magnetic field lies deep beneath our feet, a massive ocean of liquid iron swirling about 1,800 miles below the surface. This molten sea generates electrical currents that flow at incredible speeds, creating what scientists call the geodynamo, or nature's own power plant. This spinning metal forms a magnetic bubble around our planet known as the magnetosphere. It's not a perfect sphere, though. It's more like a wine sock in space, shaped by the solar wind, a stream of charged particles from the sun that compresses it on one side and stretches it on the other. One of the most remarkable features of this magnetic field is the Van Allen belts, two giant donut-shaped zones that trap harmful radiation from space. Think of them as Earth's very own particle accelerators, catching cosmic rays and solar particles before they can reach us. However, this shield isn't as stable as we once thought. Right now, something unusual is happening to our magnetic defenses. Scientists have identified a massive weak spot over the South Atlantic Ocean, stretching from South America to Africa, known as the South Atlantic Anomaly. This area is like a dent in our magnetic armor, where the field is significantly weaker than normal. It's already causing issues for satellites that pass through, leading to electronic glitches and failures. But that's not all. Earth's magnetic poles are on the move. The magnetic North Pole is racing towards Siberia at an astonishing rate of about 34 miles per year, which is 3 times faster than it was moving in the 1990s. Imagine if your compass became less reliable every year. Scientists have found evidence that Earth's magnetic field has flipped completely hundreds of times throughout history. The last major reversal occurred around 700,000 years ago. So, how does a magnetic flip work? The ocean of liquid iron changes its flow, weakening some parts of the field while strengthening others. During a reversal, the field doesn't just switch off and on. It's more like a dimmer that gradually fades down and then builds back up in the opposite direction. This process can take anywhere from a few hundred to a few thousand years. During this time, we wouldn't be left completely defenseless. The field may become more complex, with multiple magnetic poles appearing in unexpected places. It's important to note that we're not necessarily headed for an imminent flip. Scientists have identified shorter events called excursions, where the field weakens significantly but then recovers without fully reversing. These happen about 10 times more frequently than full reversals, and we might be entering one of these periods now. So, what does all this mean for life on Earth? First, the good news: we're not facing a doomsday scenario. Life on Earth has survived hundreds of these reversals before, and there's no evidence that past reversals caused any mass extinctions. The most immediate effects are already visible in our technology, with satellites needing extra shielding when passing through the South Atlantic Anomaly. As for radiation reaching Earth's surface, our atmosphere is actually our main shield against radiation, functioning like a 13-foot thick concrete wall. Even if the magnetic field weakens significantly, the atmosphere will still protect us from most harmful radiation. However, some animals that rely on magnetic fields for navigation, like sea turtles and whales, may need to adapt over generations. At the current rate of decay, it might take several centuries or even a millennium before we reach a critical point. This gives us time to prepare. Space agencies are already developing better radiation shielding for satellites and spacecraft, and power grid operators are installing equipment to protect against geomagnetic storms, which could become more common as the field weakens. We're living in a unique time where we can study this process as it unfolds. Satellites like the European Space Agency's Swarm mission are constantly monitoring our magnetic field, providing us with more insights than ever before. So while Earth's magnetic field is indeed changing, there's no need to panic. This is a slow, natural process that our planet has experienced many times before. What makes this time different is that we're here to witness and understand it. If you found this exploration of Earth's magnetic future intriguing, I invite you to subscribe for more videos about our changing planet. I'd love to hear your thoughts in the comments. What surprised you most about Earth's